it was discussed how can you bring enough base knowledge in some realms where people are not really learning that in their discipline, give them enough to go forward so they can talk more easily across biology, chemistry, computer science, and all these realms that we know are excited about AI and actually experts in AI. So that's a challenging one. I think it was Kennedy who reminded us that beware of inequity there. So if we're bringing together these great ways of providing some fundamental knowledge to people and driving the fields forward, we want to make sure everybody's got a place at the table and they're involved. So let me finish by saying another wacky idea that we discussed is how we approach the way that we are studying science. And I guess the way that I phrased it is sometimes people think of especially empirical science as an art form where it takes a lot of human creativity to understand, here's the problem, what methods and approaches can I apply to it? How am I going to do this in a day, a week, several months, across years? And that requires quite a lot of skill, prior training, and understanding in a system to go forward. And it's kind of intriguing to think how AI might allow us to take different approaches, or maybe that's too strong. How can AI possibly inform how we do science? How do we kind of do this art form that we call science? And that's a little more my phraseology and not so much echoing what people said. But I find that I'm kind of happy that our group, we didn't hold back. I felt there was a lot of creativity in the discussion. I'm probably not capturing nearly enough of it, but I've probably spoken enough. Anybody else in our group have anything they want to add?
That was a great summary, Paul. Thanks for doing that. I would just say on that last point about how we do science, just that we also raise the point that there's not only is there, like, of course, biologists. I mean, I say of course, for those who are interested in the AI, there's many different ways that can sort of come in with tools that are already developed, but that won't necessarily always interest enough or engage enough the data scientist or the AI researcher, who wants to make progress in their own domain, I guess. But I think like there could be on that, how do we do science and how do we make these, like really digging in on how we can make the models that are created actually mimic more like the hypotheses and how humans generate and investigate and carry out science. Like maybe those kinds of questions are interesting enough to try to, to hook them too, because there does, as we discussed, there really does probably need to be kind of an interplay in the most ideal sense. The give and take between the domain person and the tech person will sort of be a little bit more equal. So just being kind of aware of that. But you did a great job. Thank you.
Oh, thank you. For at least I had one fan in the room for this. They're not even in the room. They're about to get kicked out of their room. But anybody else from our group have anything to add in that I missed? Thank you for the notes, Brent.
Okay. Can I just ask a question, because it relates to the last two things you brought up, which is in academia and AI, et cetera, they're the people really interested in not doing the stuff that we already know, but we have so many young people. We were talking about the majors being completely impacted, but they're not really interested in going into academic biology because, they can do a lot better with those skills elsewhere. And I'm wondering if your group talked about that aspect of the workforce and how we can, what are the options? It seems like it's a concern. Those that stay in academia who are interested in AI are really interested in pushing the boundaries of computer science, which is great. There's a lot of overlap. But it's the same thing we face in many areas where the technical expertise is not going, at least in California, is not where I'm from, is not going to be going into studying basic biological foundational discovery.
Yeah, that's a great reminder, Susan, and I'm going to let others chime in our group who are closer to the field. But I'll just add that, I think increasingly what I'm doing in my research program is the same for many of you in the room. I'm training people who have interest in growing into the workforce other than academia. And for sure, they are as curious or more curious than others on machine learning and AI and what they could do now in their training now to give them this better workforce opportunities. But I'm saying things people already know there. I don't know if Rami or Wallace or anybody else wants to chime in.
Well, I mean, it's certainly true. There's been an explosion of sort of AI biotech startup space in the past few years. So I think there is a bio route, but it's as you say, it's mostly towards the industry side rather than the academia side, just because they can go out, and get so much money right off the bat.
Yeah. I would say, I mean, one of the things that keeps me up at night, I mean, so in my domain, of a lot of folks who want to go to industry just straight off the bat. And actually, it's not just the people I train, more and more of my academic colleagues are leaving academia to just go start their own companies because like the money is just, I mean, there's so much hype and so right now that considered to be, oops, am I losing connection? Deep science, but easier and faster in industry. I'm kind of hoping that this is like going to be one of those pendulum swings and that we don't eat all our seed corn, lose everybody to, to industry, but that it will come back and people, as the tools and the mentality of people in bio and everything kind of like continues to evolve along these axes, that it'll come back to like where the big fundamental because it's certainly going to be there, right? It's just we want to be positioned to do it, and they're probably not going to be chasing that in industry because they're going to be trying to make tools and things they can sell for the most part.
Yeah, I think we got most of that. I think your hotel is starting to dial down your Wi-Fi.
Yeah, they want to get me out.
But in all seriousness, I mean, I talk a good game, like probably many of us, of working with my institution about how can industry and academia work better together, because we know we do things differently. We know that we have strengths and weaknesses that are not the same, and maybe this is so much of this interest in the young trainees is just one more excuse to have us get our act together and just really work across these boundaries, because they're not boundaries.
Because otherwise, where are we going to be? Yeah,
exactly. Yeah.
Mm-hmm.
That's all for my report.
Who's going next? So Tom, would you like to report out breakout room 1?
Sure. Breakout room 1 was Michael, Katie, Matt, me, and Karen. I think that was it, right? So I'll do my best. I took really bad notes because I didn't know I'd be reporting out. So bear with me. And we're going to slightly follow the order of the questions and beg the conspirators to weigh in as they see fit. So what AI opportunities can be leveraged? I think we began with sort of new AI that's coming out, which is newish, explainable and interpretable AI. And this is sort of it's taking the black box nature of AI and asking it to inform us about how it came to the decisions it came to. This is going to be super critical as we try and understand things as opposed to just predict. So I did want to draw that dichotomy of prediction versus understanding. And really, that's something we have to be aware of, is this emerging space of explainable, interpretable. Michael can probably give you a tutorial on that at some point. But basically, what are the underlying features that gave rise to the classification that happened or the prediction that happened? That's exciting. I think, we were wondering, so that's one of the obvious opportunities. I think there also what Rami brought up is taking AI to aid in this cross-scale problem. So, for example, from molecular dynamics to larger scale, can you use AI in very short time scale things to train on longer time scale and vice versa? That's going to be a really important thing because most people in integrative biology generally recognize the importance of the multi-scale temporal and spatial as being a really, really important part of what biology is, as opposed to an image classifier or a car driving or whatever, right? It is very much at the heart of bio. I'll put a plug in for another aspect of AI, which it's got a pro and con, which is in the mechanistic models of the sort that Rami talked about, of the sort that people use in sort of trying to understand biology. Going backwards from the data to the underlying parameters, particularly when the data are noisy, particularly when the parameter space is massive, and I suspect Rami's parameter space would make everybody's jaw drop. How do you go backwards to the problem? How do you do these inverse problems? And there are emerging methods in AI, but then I'm going to try and channel Matt for a second, is pretty useless unless you really understand what your data represent, right? And Matt, if you can just weigh in on that. But in other words, are your data truly independent? Really understanding the basic statistics of your data before you feed it into an AI algorithm.
I mean, I think the larger issue for lots of us is, AI is about training, and your training data determine your output. And it's not just true for simulation-based things, and I also use a lot of simulation-based training, but it's especially true, right? So there are biases that can creep in. If there are unmodeled biological phenomena, they're not going to be in your set of answers, right? And so you just have to be aware of all of that.
Yeah, so I'm not an AI, and I think I need a little bit of an interpretation of what you just said.
Interpretable?
No. So maybe it's wrong. I sort of sometimes think of AI as we're like getting compression of our data into some projection of something. Are you asking how can we then go from that back?
So on the inverse problem versus the quality of the data. So on the inverse problem, it's very much given my data, which tends to be low dimensional, right? How do I go back and find out for my modeling thing? So I have a Rami-like model or something like that. How do I go back and actually understand what the likelihood that the parameters have certain values might be given the data?
Okay.
Right. So it's an inverse problem. It's a hard problem when your data are noisy. It's a hard problem when your data are limited. But this is a little case of a feedback between AI and bio, which is noisy, somewhat limited data is sometimes the nature of our world. AI, we need to actually see if we can help what AI tools can be advanced to deal with such problems. So it's actually the two-way street.
I need one more clarification, sorry, so I can learn, but if we can go to where I'm comfortable, which is AlphaFold, we have lots of sequences and we can determine or predict their structure, but there isn't a unique relationship between going the other direction. There are lots of sequences that will determine that structure, so I can't go.
Okay.
That's something different.
It's something different.
Thank you.
So let me give you an example. Maybe I'll just use Rami's talk. Rami is building forward models, and those forward models have underlying parameters. It could be a kinetic state or a mechanical transition of a motor protein or whatever. Rami, if you're online, I apologize. I don't really know. But how do you go back and say,
You're doing
okay,
a great job.
The likelihood that this kinetic rate transition is X is blah, given my data. But given the large volume of her parameter space, that's a challenge. It's exciting. Got it. Sorry about that.
No, thank
you. Great. What areas of biology are most ready versus what are not ready yet? Sort of an interesting question. The omics world, the PDB world, all of that. Protein folding has been ready. It's really unfolded nicely. Sorry. Got to know when to fold them. Yeah, sorry. But also I would say areas of neuroscience have been really successfully leveraging a lot of AI methods in circuit analysis and the like. What areas are not yet ready? We had a little bit of philosophical comment on it. We think all of biology is ready, whether it's kind of using it or how far advanced into it they've gotten. It's unclear. In some areas, particularly those with really large multimodal temporal spatial data sets.
I think we talked about that. This is the chicken and the egg. It's the unknown unknown. If we have data, then it's ready. If we don't have any data on a system, we don't know anything about the system, so it's not ready.
Right. Well, let's come to let's follow that thread in a second. Very good. So what obstacles must be overcome? Yeah, if you don't have data, that's a problem. But the other problem is certain data are just really, it takes a long-term time to get them. Like, let's say you have an LTER, the LT is something. Long-term ecological data sets, just hard to accumulate the sort of data volumes you might get in the pharma industry or in the protein interaction space. These are swimming in large data. So where data is limited, where data is noisy, where data is sparse, those are important things. In the interest of time, I'm going to sort of hop over to what roles can NSF play. But again, I just want to remind you that there's this dichotomy between prediction and understanding. And prediction is important, but prediction only works within the space of the training set that you have. So one last thing on AI is AI methods that are allowing you to push beyond your training space sets. That's an interesting emerging area as well, something to bear in mind. Also, AI used to discover equations that underlie the processes. That's really certainly become very big in the engineering world. I can see it happening in the bio world. In terms of what NSF can do, I think Matt brought up a really interesting thing is, if we really want to move the needle, so let's try this, okay? In, elevating AI for life science and bio, perhaps this should become part of the broader impacts of the proposals that are coming in. What are you doing to elevate your students, your postdocs, your colleagues, to elevate the ability for them to either partner with or develop AI methods for bio? Did I get it about right?
Yeah, I think so. I mean, I think it's as easy as we would all recognize somebody developing a new course or a workshop as, yes, that's broader impacts, but we could make it the bar lower for the things that we want to get done. Like, yeah, my undergraduate students all took classes in AI and machine learning, right? Or postdoctoral fellowships that come with workshops, right? All the NSF bio postdoctoral fellowships could come with training in AI.
Or you provide undergraduates in your department opportunities to explore AI with their data set. Things of that nature.
New classes that you might generate and things like that.
And I think that the hard thing is we recognize that sometimes those do not get credited as broader impacts.
Romi's got a question.
Well, I'm really going to get kicked out, so I'm also going to say goodbye. But
not by us.
Just that I think and it's funny because I forgot to bring it up. What we're doing with data is the whole data management plan. It can't be an afterthought anymore. It needs to be really part of the actual reviewed work that people are held to do. And it's similar, when you say put it in broader impacts, I appreciate that, but I also think let's try to move people to get it into what they're actually doing in a more concrete way, because too much of that gets like, okay, they put in the words and then they don't actually do it. If I can say it. Okay. And they're breaking down my door to clean my room.
Romy, before they kick the door down, I'd really like that idea that you could we could change the requirements for NSF could change for the data management plan to be much more proactive, so to speak, so that the data is managed in a meaningful way.
I mean, I think so. I think it's
Yeah.
something to be discussed.
Yeah.
It's that way with NIH now. You have to have that. Can I just do a couple more items?
Yeah.
Nope.
Bye, folks. Thank you so much.
I want to say thank you on behalf of all of us, Rami. It was terrific to have you here. And if there's a late bill, let me know. Bye.
Okay, thank you.
Yeah.
Bye.
Rami, thank you. Right. The other things at NSF Bio, we were really impressed with NAIR. And we had, of course, the usual comments from bald guys about NAIR. But we felt like things that NSF can do is things like getting the word out about NAIR. It's brand new. So this is a great resource. We think it's going to have the potential to be pretty transformative. So we're very excited about that. And, you know, other things that NSF has, just again, getting word out on the Jetstream, NAIR, access to compute. That's part of what NSF does. It's not like there isn't word out, but that can be probably popped up a bit. Well, I think that's about it. I had one reflection on the prior report out, if I could, which is one of the areas of AI that seems to be underattended in bio is lab automation and the concept of laboratories actually having AI design experiments, tests, and generate hypotheses, actually all the way through the automation part of it. It's an emerging and unattended area. Groupies, anything?
Okay. And last but not least, breakout room 2.
Yep. So I think I've been voted, and that was Hank, Gail, Maria, Pam, and Michael. And I think that we divided this pretty much into the themes, into the questions. We identified as something that might be ready. Motif pattern recognitions in nucleic acids. We don't necessarily agree that all the omics are ready for this, and I'll come back to that in a minute with one example of why we don't think that that's ready. Remote sensing data, the use of collections for example, paleogenomics, species and distribution and phenology models based on collections and museum specimens. I mean, that's something that has been done already, and it continues to be done. Extracting plant trait information from text, species recognition and associated traits. So this is probably all pretty much ready. A little bit less ready is the integration of genome into physiology and demography, or using genome information as a way to model physiology. And I think that one of the challenges I really want to bring up, and there might be an opportunity for NSF, and it goes back to a little bit about what Tom was saying about the all omics being ready, is the fact that we really don't understand how linear the information is when you go from genome to a phenotype, right? I mean, we don't really understand to what extent epigenomes, variation in mRNA translation, post-translational modifications, and so on, really impact the information that is encoded in the genome into ultimately the outcome, whatever the outcome is. There might be an opportunity for other places in the genome encoding that information. So there might be an opportunity for making models which are even more complex, but I don't think we're even close to thinking about that. The other obstacle and opportunity that we were identifying.
Can I ask a question, Eric?
Yeah.
Sorry. So do you think though that, okay, since I agree you can't always get from omics to physiology or phenotype, but do you think, I mean, this is a general question, that AI is at the point, because I know that in some modeling scenarios using AI, it tells you that you're missing data. It doesn't tell you that what data you're missing. It can tell you that there's something missing in your data set.
Sure. I mean, so you're making a model that is not necessarily satisfactory, and you will know that your model is not necessarily good enough and that you need more information.
Yeah.
I mean, in many words, that's what I'm saying,
Okay.
right?
So, but that's still, don't you think that's somewhat positive? Because before, if you just assumed you had enough data, you spend half your career trying to wrangle the data into your model to convince yourself that you had enough data. Whereas now you keep on in some modeling systems, it will tell you that you just don't have enough data, or either your data is not deep enough or you're missing a data set. So post-translational modifications are telling you that you can't explain your gene expression data adequately. Things
Yeah,
like
but I would
that.
argue, Mike, that we don't even know if we need that data. That's my challenge.
Okay.
Right? We think that with that's data that's important, but we don't really understand. We have, I mean, you can make models perhaps just based on genomic information that may or may not be correct. And I think it's a game we'll have to play. Okay.
Okay.
My gut feeling is that you will need much more data than what we have, but I don't really know because we don't have done the models. The other area that we identified as being a significant opportunity is going back to old texts and developing better text mining tools that can be really mined for a number of different questions. I mean, the challenge here is how you export that text into formats that are suited for each one of the different fields to be able to mine it. And I don't have an answer on how that could be done, because I think that if you're coming from the systematics perspective, you will probably have one set of formats. If you're coming from a more molecular biology perspective to try to inform on gene structure and so on, you would be using a completely different format. But I think that there is a big opportunity in all publications that are stored and that we're not currently using because it's very tedious to curate everything by hand. One other area where we think that there is a great opportunity is to develop more clever teaching and instruction tools, using AI for doing that, and also for improving our ways of assessing the ability that we've had in providing that instruction. And I think that that's something that might actually change significantly the way in which we teach moving forward. The big gap that we found is that we don't really, so we agree that it's not necessarily necessary to teach biologists how to code, because that might actually be done by AI very soon. However, the challenge that we have is how to articulate questions that can be understood by a computer. Okay, and I mean, we were just talking about how difficult it is for us to explain even some tasks that we do daily. I mean, the one that comes to my mind is walking. If I have to explain how I walk, I probably will have a very, very hard time trying to explain to a computer. It's going to be even worse. So maybe that's an area where we could be training students better, is how to articulate that communication with a computer in a productive way. So where do we see NSF Bio coming in? We think that postdocs is an area that is probably underfunded right now. Postdocs are probably at the right stage to be able to adopt new methods, new technologies, new ways of thinking. But the number of postdoctoral fellowships is pretty reduced, and they could actually be tailored into specific areas. We also think that advanced graduate student support in particular areas would also be great as a transition to go into postdocs, and perhaps also as a way to keep them in academia. And I'm talking about once normal fellowships expire, last 2 years or so before they transition into the next career stage. And finally, one other comment that came up is that our current model for training grad students, NRTs, are really not giving us enough time. It's 5 years normally, and not giving us enough time for the faculty to adapt to a new area. I mean, because they're really interdisciplinary, transdisciplinary. So first you need the faculty to be able to come together and then do the training. And then by the time that we get to be able to execute some of the things, the 5 years are over. So perhaps having the ability to renew NRTs in a competitive fashion for at least one round would allow us to better take advantage of what we have learned in the first 5 years. Anything else from the team?
Yeah, I have a comment that about something that the first group that spoke also highlighted. I think it's frightening to all of us to see the possibility that AI may think better than we do. But there's this issue of metacognition that is not unique to biology, that it crosses all the sciences, right? So how do we think? How do we come up with a good question? What are the processes? What are our thinking processes? There's plenty of data out there. And so this could be something that, would getting different people to kind of inform on what is happening here and try to understand, can we develop ways to teach students how to ask good questions by learning from what we know about how, scientists that ask good questions. And this is I think, I don't know if we're speeding up the replacement of the human mind or simply it's just another way to get, I sort of see AI as a way to help ourselves better understand how we think and where we fail in our thought. And so I think this is a great opportunity.
So Maria, I agree with you. I noted that as well. But ironically, I think that this is something we have out there. When philosophy programs all used to be in science colleges, scientists took a great amount of time to study how to think about science and what questions to ask. And there's probably time for a little renaissance of that. It's not very popular, but it's very, very necessary, I think.
Unavoidable, I think.
And I think it's not just how to ask questions, it's also how to communicate complex ideas.
I think the only other thing, great job on the reporting, Eric. I think the only other thing that we discussed a little bit was maybe having partnerships to help support some of these training activities with industry. And of course, there's the fear that we might lose people to industry, but it could be a way to help support postdoc and graduate student fellowships along the way.
I just follow on the postdoc comment. Matt brought up interesting. We talked about postdocs as well, and the one concern is if you have a bunch of NSF postdocs and they're all each doing something slightly different in a different lab, you lose something. So the idea would be that if you had a postdoc call, make sure you have a workshop that's national. So you bring them all together and you get a more evenly distributed experience, and it's more scalable. So that's sort of a slight twist on the way the postdoc programs have run.
Just to add, because I didn't in the beginning about the partnerships, it's a big focus of our current director and to leverage what the NSF does and not rely just on our government funding, but figure out ways both financially and intellectually to partner for mutual benefit.
Okay, thank you for a great discussion. We should use this opportunity, something we were going to do later, but I'm not quite sure who's going to thank Paul for his service. But since Paul, I'm going to hand this over to Susan because Paul can't join us this afternoon, but he don't get away.
He's escaping, and
you don't escape the roast, Paul. I'm sorry, it's coming now.
Oh, but in all sincerity, it's been a pleasure serving on this committee for the second time. I mean, I really, people talk about committee work that's fulfilling and rewarding, and I got to say, this is one of the best ones I've had in my career. I mean, y'all are just amazing. I literally will miss interacting with you, and I suppose I could always be asked to serve again. I know that that's a possibility, but I was telling Karen and Mike, I didn't realize this was my last meeting until I saw it on the agenda.
Oh,
so don't take that as a tip to do anything different. But But I couldn't be there in person this time, and I apologize for that, but you're excellent, and I appreciate the opportunity to even be asked to serve on this committee. So thank you.
Well, Paul, thank you for everything. I actually served with Paul in his first tour of duty, and was so thrilled to see that you were back when I came on the other side of the table. And I'm not sure, but I think you may have timed out, and we may not be able to even consider you.
Oh.
So you may be relieved until you come to the other side of the table, which is really a beautiful, wonderful experience too. So we could have you do that. No, thank you for everything.
Thank you,
You've been
Susan.
totally supportive, and we are going to send you
Oh,
this for
awesome.
your office, because it's blurred, but we know it could use some more posters up there. And I believe you'll be maybe in Washington in June for the Human Frontiers and Science Program, and
Exactly.
NSF participates in that. So I look forward to seeing you there.
Oh.
And I don't know what you're doing this afternoon, but I hope it's fun and important, but we'll miss you here. So thanks for everything
you.
and enjoy. Take
Thank
care.
you so much, Suze. I appreciate it. Oh, very kind. Thank you so much. I appreciate it, everybody.
All right. Thanks,
Go
Paul.
enjoy your lunch, because you deserve that too.
Okay, so we will adjourn for lunch, and we'll come back at 1:30 for a brief meeting with Suzanne Barbour, and then we're going to prep for our meeting with leadership. And I will be sending some of you little notes and emails as I eat my lunch. Be warned.
Thank you, Michael. Katie, she's
Thank
still
you.
there. Thanks so much. It was great. Give you sort of a little perspective. I'm sure you all know, but what's the purpose of this, right? So this is an advisory committee, and so you give us advice, but it's also an external statement that you can give the rest of the NSF directorate about what you think the status of biology is. Are we meeting our goals in the status of biology? Are there opportunities we could be going from? And so that's, your chance. You've all been on external reviews for departments, and people sometimes hear outside voices in a different way, or more or less, whatever, than they do internal. So pick and choose what you want to say. That's not for me to say, but that I think is what she's here. And
All right, I'll
go
give you
on.
something to ruminate on over lunch. So these are some of the points. So I'm going to give I thought some of the things we discussed yesterday would be just best as an introduction. We talked about funding, individual investigators, Casa Bio, our support for what was being done, the bioeconomy, so on. Then we were going to talk briefly about, because we all had a very positive response to the EPSCoR presentations and what was being done for HBCUs. We're impressed with Bio's role in that, but then there was this to emphasize the continuation of outreach and training opportunities that would come through that would continue. And Kennedy won't be here, but he said he'd give me some comments about, because he was intimately involved in one of the hosting events. We wanted to come back to the post-bac training and that component of the workforce development of the bioeconomy, because of something that I think we as a committee are all seeing, is this significant number of undergraduates who are taking this professional development year, what we'll call it, before they make a next decision. And so that NSF is in a position to support that, to maintain an adequate workforce for a lot of the initiatives. And then we're going to come to I think we want to give most of our time to discussing AI. I mean, I got a very positive feeling about what's going on. And I think that what we should use, to Susan's point, is our opportunity to say what we think is interesting, what's worth pursuing, and to put ideas out there. I mean, several ideas came out now about, someone brought up RCN, someone else brought up broader impacts. Different ideas came up about how the implementation could work. But also, I think it's important that we give some of the higher level thoughts. So, we had different ideas about what was ready and what wasn't. And I think we should be honest about that there's not one size fits all for this. and to give different ideas around that. So think about that while you eat. I'm still digesting the AI stuff a little bit, but I think we have to have a good, to Susan's point, is to give our opinions and to give advice with the advisory council on where we think NSF should be going with this. Tell them what we think works, what doesn't work, and what would be good to start doing. That kind of simple analysis. Does that cover it, Susan, you think?
Sure. Yeah, your choice.
All right. Okay. See you
Thank you.
shortly.
Yeah. They haven't officially stopped streaming us yet, so just be aware. You don't have to go anywhere. You can leave, just, you know.
I'll go.
Just know your mics are still hot.
I'm just going quickly to grab
Thank you
something.
for Yeah.
No, I need Okay, welcome back, everybody. I hope you all had a good lunch break. I'm pleased to introduce Suzanne Barber, Chair of CEOS. CEOS has recently written a new report on rural STEM. It's a great connection to the discussion we had earlier in the meeting on funding in EPSCoR states. Suzanne, will you give us an overview of the new report?
Thank you. Thanks everybody for the opportunity to tell you about our report. I think somebody's got the slides for me. We can get those going.
1 second, we're working on it.
They're coming, Suzanne.
If not, I'm happy to run them myself.
It might be easier if you show them yourselves, if you don't mind.
Sure, happy to do that. Okay, are you seeing regular presenter mode or are you seeing my notes?
See your notes. We see your notes.
Okay. How about now?
Yeah, it's good.
Okay, perfect. Well, again, thanks everybody for your time today. I'm really excited to tell you about our latest report. This is a special report, but it's kind of part of our most recent series, Making Visible the Invisible. And this one is going to focus specifically on STEM talent in rural America. I want to start by acknowledging the writing team. You can see their names over here on the left-hand side. We were led by Tabitha Dobbins, Jose Fuentes, and Kay Husbands-Feeling. Former chairs of CEOS were writers, Cynthia Lindquist and James Martin II, who's now the vice chair of CEOS. And I also want to acknowledge the support we got from folks in bio who were incredibly helpful in helping us to identify projects to talk about in our report. And in particular, Karen was really essential and helped us a lot when it came to identifying projects that align with this very important report. So I'll start by giving you a sense of why we did this. And this was actually a part of the charge to NSF in the CHIPS and Science Act back in 2022. Effectively, what they asked NSF to do and what CEOS was charged with doing was to generate a report that, first of all, described past and present policies of the foundation in relationship to engagement of students in rural STEM communities. And in particular, the focus was meant to be on K-12 students. So that's what I'll focus on today. They also asked us to do an assessment of trends of participation for students from pre-K all the way to 12th grade. That turned out to be more challenging than we thought it would be, but we can share some of that with you today as well. And then finally, they asked us to do an assessment of policies and activities of the foundation, along with providing some proposals for new strategies to further and even more effectively engage the rural STEM population, with the ultimate goal of seeing more folks from rural America involved in STEM and in STEM careers. So I think to get started, it probably makes sense for us to first get together on some definitions. And why don't we start by defining what rural STEM education is? So this is one definition that comes out of the reference that you see down here at the bottom. And it basically characterizes rural STEM as having 6 characteristics. The first is that education occurs at a distance from large urban areas. That's basically the definition of rural. Education can also have less access to resources, such as high quality professional development and curricula. It tends to take place in small schools. It tends to cooperate and meet the needs of the rural community and the local economy, and that's an important piece there. And education is placed or rooted in the lives of the community and families, and that family piece is going to become important too. We'll talk more about that later on. So now that we have a common definition of what rural education is, let me give you a snapshot of what rural education looks like, and that's what's on the next slide. So let's start out with the information that's kind of in the center of the slide here. Back in 2019, 2020, about 90,000 schools were what we call traditional public schools. And as you can see, they served more than 50 million students. Of those 50 million students, about 29% of them were in schools that we would consider to be rural schools. So you're talking 9.8 million students in 2019, 2020. The next bullet shows you the demographics of those students. And as you can see, at least I hope you can see it, they're overwhelmingly white, 68%, but a significant percentage, 15% are Hispanic, 9% are Black, of the Native American, American Indian and Alaska Native population. That's about 4%, and Asian amounts to about 4% as well. So this is a diverse population of students. And when we think about the diversity of the STEM workforce, this is certainly a group of students that we don't want to overlook. And then finally, when you adjust for cohort graduation rates, when you adjust a cohort of graduation rates, the rate of graduation for students from rural STEM school, from rural schools is very comparable to that in suburban areas, so almost 90%. And that's reflected also when you look at some of the scores of the NAEP, or the National Assessment of Educational Progress. This is a test that's given to 4th, 8th, and 12th graders, and it tests for science, for math, and for reading. And I've got those statistics here. It's kind of, there's a lot of information there, so it might be hard to read through it. But to summarize, if you compare the scores of 4th, 8th, and 12th graders on the reading assessment, the math assessment, and the science assessment, the students from these rural schools actually look very, very similar to their counterparts who are not in rural schools. In short, when it comes to basic skill sets, they perform just as well as anybody else. But notably, and I'll just quote this from our report, research results show that rural children are less likely to attend college, and those who do attend are 60% less likely to enroll in STEM majors and less likely to persist in STEM fields of studies than are their urban and suburban peers. So although these students are well prepared, they're either not going to college, or if they go there, they're not going into STEM. The question is obviously why, and then a second question is, well, what are we going to do about it? And so I'll deal with that second question and talk a little bit about what NSF has done and is currently doing to engage students, rural students in STEM. So this is a summary of some of the analyses we did in preparing the report. And in doing these analyses, we looked at projects, we looked at programs, we looked at news reports, we looked at anything that would give us a sense of the degree to which NSF has engaged rural students in STEM. And what you see on the top here are things that are happened in the past. On the bottom are some of the present programs that are being run. Please don't test me on all the alphabet soup. I know I will fail that test. Of all these programs, so I believe it's only the RSI, the Rural STEM Initiative, that was specifically targeted at rural students. The rest of these have engaged rural students, and to various degrees and on different levels. And so some of them have engaged rural students through informal science education. Some have focused on systemic reform and change initiatives. Another group have focused on culturally responsive pedagogy. And then another big group, the Noyce is a good example of this, have focused on teacher education and K-12 STEM career development. And the long and the short of it is that NSF has a longstanding and continuing commitment to rural STEM education, as evidenced by the projects and programs that it has run and continues to run. I think it's of interest to take a look at these projects and programs and how they've changed over time. And one way to do that is to do a word cloud analysis of the project summaries to get a sense of what people were focusing on when they submitted these projects. That's what you see in this slide. So the S, T, E, and M, obviously that's STEM, are broken down into the time period from 1980 to 1993, that's the S. 94 to 2008 is the T, 2009 to 2023 is the E, and 2019 to 2023 is the M. And obviously, the larger the text, the more times that word showed up in the word cloud. And I think it's interesting to see how things have changed over time. Early on, the focus was on teaching and students. The word science shows up, but we don't see STEM. We see a little bit about girls, for example. The focus seems to be on just kind of basic education. And then when we get into the 1990s, now we start seeing things like technology, a focus on some of the things that might limit the ability to deliver rural STEM education because the technological needs or the technological infrastructure may not be strong. Again, we see words like science, we see systemic, we see learning. Then we get into the 2000s, and now we're talking about teacher education, that is preparing teachers. And very importantly, we've moved from talking about science to talking about STEM, recognizing that this is a larger family, a larger group of potential career paths that we want to prepare students for. Then finally, when we get to the M's, are the most current projects that are funded now, words like collaborative show up. And I think that's a very important piece of this as well. And CIAS is particularly excited about this idea because it starts to engage, it starts to invoke the idea that rural STEM education is best. It performs best when you have strategic partnerships. that allow rural STEM schools, rural STEM students, rural STEM teachers to interact with other people who have interest and expertise in STEM. So I want to pick up on this collaborative piece because I think it's a really important part of the puzzle, and talk about 4 trends that we noticed when we looked at the projects that have been funded over time. And one of those indeed is this idea of partnering relationships. The long and the short of it is that these funded projects have gone from one student, one classroom to projects that tend to be much more complex, involve many more partners, and we think are ultimately positioned to be much more impactful than they were in the past. We've also seen a trend toward projects that not only focus on the doing, but also focus on studying the doing to figure out what interventions are working the best. In other words, research on rural STEM education has increased over time, and we're seeing that in some of the project summaries that we reviewed. We've also noticed that these NSF-funded projects are providing students with cutting-edge opportunities to engage in STEM. And importantly, this goes beyond high school into middle school and even at the elementary school level. And as you'll see later on, we think this early kind of intervention is absolutely critical to ensure that students not only recognize STEM as a career path, but get excited about it and persist and ultimately find themselves not only in college, but majoring in STEM disciplines. And then finally, we're also seeing a trend toward the development of students for STEM careers, not just as a pipeline, as in you start at point A and you go to point B, but as a pathway. In other words, the idea that different students are going to have different pathways to get into STEM, and that ultimately, in order to get students into STEM, we have to embrace those different pathways and kind of meet the students where they are. So I hope this gives you a sense of the trends that we saw overall when we looked across all the projects that were funded. Many of these funded projects are funded through the STEM Education Directorate. But interestingly, we're also seeing some really interesting projects that are funded in the biological sciences area that I think you might be interested in hearing a bit about. So I'm going to spend the next couple of minutes talking about them. And you may remember we've had conversations before when I was in the BioAC, talking a little bit about LTER and NEON as being strategies to engage students and to broaden participation and engagement of students from underrepresented groups. But I'm going to show you on the next couple of slides that both LTER and NEON are indeed being used to engage students from rural areas. And I'll start by talking about LTER here by showing you 2 sample projects. On the left-hand side, we're highlighting a project called the Schoolyard Series. This is a series of illustrated children's books that focus on basically teaching students and their families about ecosystems. Importantly, these books have been put together by LTER sites across the entirety of the continental US, Alaska, Antarctica, and islands in the Caribbean and the Pacific. So a terrific way to engage students where they are, so to speak, engage them in not just where they are in terms of education, but also geographically, and also engage their families, which is an important piece of the puzzle when it comes to getting students excited about careers in STEM. And then on the right-hand side, this is a project from the University of Oregon. It actually partners the University of Oregon's Environmental Leadership Program with the Pacific Tree Climbing Institute and the U.S. Forest Service. And it basically brings Forest Service lessons into the classroom so that K-12 students get a sense of how what's happening in the forest ultimately relates to the science that they're studying in the classroom. Again, kind of a place-based initiative and an opportunity to engage students where they are geographically in ways that help them appreciate why science is so important. On the next slide, I want to show you some of the things that are being done with NEON data. And we're really super, super excited about this. I won't go through this in any detail, but just to tell you, there's a project in Hawaii, there's a project in Massachusetts, a project in Puerto Rico, a project in Wisconsin, and this is just the tip of the iceberg. There's even a project here bringing NEON data to teachers in Title IX classroom by Science Buddies that extends nationwide. So long story short, the data that are being collected, those rich data sets that are coming out of the NEON observatories are ultimately finding their way into these K-12 classrooms in rural settings. And again, we think that's an exciting opportunity to engage students who are just on the cusp of making decisions about what they want to do with their lives and basically make science come alive for them, and also teach them about the importance of data. And you can imagine how valuable that is to budding scientists. So overall, we think this represents a genuine commitment on the part of NSF to engage and be inclusive of rural communities, rural teachers, rural students, and importantly, when we say community, that includes the families. And again, we think it's that wraparound, that kind of hug that becomes important when it comes to not just engaging students, but ultimately retaining them and hopefully inspiring them to pursue careers in STEM. This is founded on a long history of a variety of projects, and you saw that in that timeline in the early slides. And importantly, these projects engage not just K-12 students, but also their teachers as well. You may remember in the word cloud, there were a lot of signals of teacher preparation. And then finally, although the education directorate has really been leading, the STEM education directorate's been leading this, we're really excited about the potential for engagement of other directorates as well. And in the report, when it comes out, you'll see there's a whole long list of appendices, one of which shows the investments that are coming from across the NSF to support rural STEM education. Now, that said, we're not where we need to be. Obviously, we still have a ways to go. There's clearly a need for more funding to address inequities and disparities among rural communities, to first of all, make sure that some of these best practices we're learning from the projects that have been funded can be replicated and ultimately scaled to other communities. And of course, we would love to see some of these innovative efforts transformed into opportunities, new opportunities to engage students, new opportunities to engage teachers, and again, new opportunities to engage those supportive families. Now, we recognize there's some headwinds. A lot of things are happening that complicate our engagement of our continuing engagement of rural STEM students. The demographic cliff is one we all talk about in higher ed, and the degree to which people still view college as a value add. When we talk about rural STEM, we have to be concerned about internet availability, in particular broadband availability, to ensure that the delivery can be done in an appropriate manner. School choice and admissions policies become issues that we need to be concerned about as well. Some concerns about lags in student achievement. That said, the students do seem to be doing well on the exams. The question is whether they have the same opportunities on the experiential side as students do in the cities and in suburban areas. And then finally, the idea that in some cases, these rural schools are under-resourced, and that can make it difficult to address all the things that you see on this list of headwinds. Although there are headwinds, there are also very substantial tailwinds, and that's really what CEOS want. We really want you to focus on and from CEOS. We want you to recognize that there are success stories, that the schools are indeed community centers in rural communities, and that in turn can make it easier to engage the families. And again, we think it's that family involvement that's the wind beneath the student's wings. It helps the student to understand why STEM is so important, appreciate that it's a viable career path, and ultimately stick with it into college and hopefully into their final career decision. We think place-based learning is incredibly important because, again, when you see science out of context, it loses its meaning. But for a student to see STEM in the context of a community they've grown up in, the economic challenges their community has, the economic opportunities their community has, we think that's just incredibly empowering. And again, I think a very strong indicator of the potential for interest in a career in STEM. The potential for dual enrollment programs is something that we think has the opportunity to not only enhance the engagement of rural STEM students, but ultimately help them to make that jump into the college in a more seamless and efficient manner. We love the idea of taking advantage of natural resources like you saw in some of the LTER projects that I described just a couple of minutes ago. Again, all of this depends on strategic partnerships. And although this is cut off at the bottom, let's not ever forget the importance of economic progress and the economic stability of rural communities and the degree to which STEM becomes the wind beneath the wings of the entire community and not just the student. So in summary, to summarize our recommendations that will come out in our report, which is we hope will be transmitted to Congress in the next couple of weeks. We think it's important to focus on STEM literacy. Again, that literacy goes beyond just the student, beyond just the teacher, but to the entire community, the family as well. We emphasize the importance of access to high quality STEM teaching and learning and training, and that impinges on not just the preparation of teachers, but access to broadband internet and to cutting edge laboratories and all the sorts of resources one needs to make STEM really come alive for a student. We focus on that idea of early engagement with the research community so the students can start to see themselves as STEM researchers, or I should say as STEM workers. And the earlier that happens, we think the more likely it is that students are going to plug into the pipeline, or I should say into the pathway, and ultimately find themselves in college as STEM majors and ultimately in STEM careers. And then finally, we're CEOS, and so we're always focused on inclusion in the STEM workforce. And we think that engagement of students in these rural STEM communities becomes a really outstanding opportunity for NSF to continue to broaden participation and increase inclusion in the STEM workforce. And so that's just a very short summary of what our report is about. Again, it is not out yet. We were hoping it would be out before the BioAC meeting. We expect it to come out in the next couple of weeks. I am happy to answer any questions if you have them.
I think, hi, Suzanne, this is Tom Daniel. Good to see you again.
Hi.
We miss you.
Good to see you.
I am moderating your session. I see there's already some hands up. Hank, you want to just go ahead and unmute and maybe let your face be seen?
That's me, right?
Yeah, all day.
Yeah, okay. Great job, Suzanne, as usual. I'm wondering, the kind of the stereotypical way of thinking about students in schools in rural areas is that, like you said, under-resourced, maybe better connected to environmental kinds of things and things they can enjoy, having relate to natural resources. But the thing I'm thinking about is, this tendency of students in those areas to move to urban areas after high school. And so is there any sense from the projects you highlighted that that is in fact what's happening to these students after graduation from high school, and and are these students prepared for colleges in the urban areas?
Yeah, it's a great question, Hank, and I appreciate that. I think there are a couple of lenses to look at that through. The one thing I will preface this by saying is that there is no database that documents the engagement of each and every rural student who engaged in one of those projects that you saw on the timeline. And that was part of our challenge. It was part of our charge, ultimately a part of our charge we couldn't meet. So instead of looking at this by individual students, we looked at it by projects. As we went through the projects and read some of the underlying literature, it did become clear there are concerns in rural STEM communities about brain drain. And quite frankly, the idea that you send a kid away to college with all the promise of the community, all the expectation that they're going to come back and put that education to work in the community, and you never see them again. So that is clearly a concern. It's something we certainly have to keep in mind as we educate these students. And I think the more we can get students connected with local industry, the more we can show them that there are opportunities to apply their STEM skill sets back in the community in ways that enrich the community and are also satisfying to them, the more likely it is that they're going to come back to their rural communities and serve the communities. But you raise a very, very important point. The brain drain is real.
Thank you.
Thank you.
Suzanne, I'm going to go ahead and ask another question because it's room for more to pipe in. You showed a statistic that I found sort of surprising, which was that the majority of rural students that go on to college don't major in STEM. That I found that surprising. And I guess I'd love to know, is there a common theme that they're pursuing, or is it that they think STEM is simply not available to them as a discipline?
Yeah, it's a great question. And I honestly, Tom, I don't have an answer to that. I think it's possible that rural STEM students are concerned that they haven't had the same sorts of access to high quality laboratories and to role models, to people who have STEM careers as students and who come from the suburbs and the cities have, and they may be afraid that they can't succeed in STEM. They're probably not aware that their test scores on the NAEP assessments are comparable to their peers in non-rural communities. So, you know, the way I see it, I think this is all the more reason why it's important to engage students early and often. And, you know, once a student gets into the pipeline, once you start to engage with the student, try to continue engaging them in ways that make sense to them and are valuable to them. I also think there's a strong opportunity for the community and the support network for the students, the parents or the guardians who are taking care of the students to shore them up and provide them with some confidence that they can be successful in STEM. And then the last thing I would say is I think sometimes STEM gets a bad rep too. You know, if you don't know, if your next door neighbor isn't a scientist and you don't know somebody who wears a lab coat or goes out on a boat and you know, tags fish or tags birds, you may have this picture in your mind that they're all, you know, they all have crazy wild hair and pocket protectors and, you know, they are socially awkward. And so I think the other challenge I think is having role models and not just having role models, but having role models who look like the students, talk like the students, have the students' lived experience and can say, hey, I came out of this community too. STEM is a great place to be. It's a rewarding career and you ultimately have the opportunity to give back.
Yeah, thank you. I see Rob, you're up next.
I wanted to follow up on that last point, and I wonder if the lack of students from rural areas choosing STEM is a perception of a lack of opportunity to go back and give back to their communities and choosing something else instead where they feel that they can actually go home.
Yeah, I think that's an interesting point. And it goes back to helping students understand the variety of career paths that are open once you opt for a career in STEM. You know, having a career in STEM doesn't necessarily mean you have to be in a biomedical laboratory in a big city. You know, there's an awful lot of really important STEM work that happens in agricultural fields, in rural communities, in the forest. What a wonderful opportunity to leverage the LTER network, for example, to give students a sense of how people who are STEM, bona fide members of the STEM workforce are actually working within rural communities and making a difference.
Additional questions for Suzanne? Oh, go ahead, Matt.
I have a question. You brought up a very interesting point about opportunities at universities that are maybe closer to rural communities, right? So now I've heard the phrase M2 or M1 or PUIs. I never really thought about, you know, maybe there just aren't as many opportunities for them to major in STEM fields that if rural students really are attending those schools at higher rates. Do we know if they have lower rates of STEM majors at schools that are at universities, colleges that are attended by these rural students?
Yeah, it's a really good question, Matt. I actually don't know the answer to that either, but it does give me the opportunity to raise another issue to think about, and that is first of all, community colleges and the value add that community colleges serve as bridges to 4-year degrees. A significant percentage of our students of color, for example, start in community college and ultimately use that as a bridge. And when it comes to rural STEM students, community colleges tend to be bridges for them as well. Let's also not forget the minority serving institutions. You know, in particular, when we look at some of the tribal colleges, for example, they are also conduits into STEM careers. And I think they're an important part of the engagement mechanism for underrepresented students and rural students. But yeah, I don't have an answer to your question. It's a good one. You may be right.
I have no idea.
Thank you.
Well, Suzanne, thanks for beaming in from Duke, or at least virtual Duke. And we wish you good luck. I think we're on to our next agenda item.
It was good to see you all. Thank you so much. And look forward to seeing that report in a couple of weeks.
Okay.
Bye-bye now.
Now we're going to move on to preparing for our leadership meeting. So I have to say I feel like one of those coaches where like lots of the players aren't here anymore. Like this, lots and lots of people aren't here. So if I ask you to do something, it is because I trust you. It's not because someone else isn't here. Please believe me on that. My plans haven't changed. It's all brilliantly planned. So, well, no, I had some plans. I was like, where's so-and-so? And so some of you, I basically have retasked some of you. And okay, I put what I have in the chat, then we can discuss it. It'll be easier. And then we can talk through it. Sorry for that. What? It's a two-part post, so watch. Oop. Okay, so just to give you the background, so Karen sends a summary of what we've discussed and what Karen Marangel and Brian Smith can expect that some of the kind of topics we'll be discussing. They got that yesterday. So I've taken some of that out, and it was a good prompt that some of this, so the first paragraph, what I've written here is a guide to summarize some of our discussions. I think we had some very positive outcomes yesterday, and some points we wanted to bring across, but we don't need to discuss at length so that we can get on to the things that matter more. So Kennedy left before he could provide Bart with some help on on what I was hoping he would be willing to do, which was to talk a little bit about. So Kennedy expressed yesterday some thoughts that the EPSCoR state, the presentations were very, very good. They were well received. And it was about next steps and to emphasize the need to keep building on that. And since Hank, I think you are quite knowledgeable around this area, I thought you might be able to talk a little bit more about this, how you see that playing out in Louisiana and in some of those. So just to, for example, it came up in our discussion about what are those AI centers called? The
AI Institute.
The AI Institute. So Matt pointed out that none of the lead institutes were in those EPSCoR states and that they've got a networked out. So some of that implementation seemed to be very, very important, that would continue to roll out. So I think that would be a good point to raise. I don't know what everyone else thinks, but it seems that there was such good momentum from the start that should probably be continued. So the second point, and I just go through these and we can discuss them more. So both Wallace and Rob at different points during the meeting have talked about some of the training challenges. I know that Wallace had talked about, in particular, about the students taking their, I think Wallace, you called it a professional year, not a gap year, professional development year, something like that.
He's en route between his home and university.
No,
okay.
I'm not yet. I'm actually still here. Yeah. But thanks. I'm going to be en route soon, but I'll be still using my phone to dial in, but it may be a little bit of a glitch. But yes,
okay.
Right now.
So I thought I really liked the language you used, Wallace, to describe it. Was no longer a gap year. I think you called it a professional development year, exploration year. So, and I think that Rob had also expressed concerns about what we would do with students in that space. So if between the two of you, you could just express your concern, not concerns, I think it's about opportunity, because this is a kind of growing demographic, that these students who are still very interested in STEM and are exploring where that will take them in between college and graduate school, or I don't want to say graduate school is not a work setting, but a sort of a professional setting, let's call it that. Well, graduate school's a professional setting. What would you call it if it's not graduate school? It's
I assume not
an
totally
employment whatever. So it's that gap where they decide what to do next.
And Wallace, you
Well-
said you had really good data that supports that the more intensive of a research experience in the
Yeah.
background of a student, the greater probability of success in graduate school. I'm not misremembering that, am I?
Yeah, no, that's right. However, what we did not track was what Tom mentioned, which was we didn't actually track time to graduation because it may well be the case that that additional preparation time leads to a faster graduation. But we don't actually have that data. Well, we really have. I mean, I'll tell you what the actual data was, which was we went through and basically tabulated students that had a problem that basically barely got out, took too long, took intervention by thesis committees to get them out with a PhD or didn't get out, and then students who basically, were at the top edge, meaning that they had really good papers at the end of the day, they got really good jobs or postdocs afterwards and have gone on to do great things. Those two were it was very predictive. The only thing that predicts which of those two batches anybody ends up in was the extent of prior research experience. GPA does not predict, institution does not predict, strength of the letters does not predict, standardized testing does not predict. So the only thing that's predictive was research experience, and the trick there is that that's not always equitable, because depending on your situation, you may or may not have the opportunity to do a lot of research as an undergrad. So that's why I think postbac is really important.
Okay, so I know what everyone else thinks. I think that really resonated with me. I think you're right, Robert. It was that date that when Wallace pointed out that it's so striking that impact it has on the success.
Can I raise a point, because I was just double checking Matt, who was looking at the AI Institute's map and seeing a dearth of EPSCoR states. There is actually one in Oklahoma. So let's not make our statements so absolute, but perhaps predominant or something like that. Give a little bit of a qualifier just to be accurate. Thank you.
All right. So Bart, Hank, don't just tank the whole thing in your description of it.
Oh, there's one.
Okay.
And of course, they're not bio, so we don't control that, is what I'm saying.
Yeah, but it was that point that Kennedy brought up about for bio's continued success with EPSCoR, for that to be important. So the next thing that came up for me as we switched into AI, and I'm sorry, my cut and paste has been, I don't know what's gone with my. So I think it was really about opportunities, as it was titled, opportunities and bottlenecks for advancing AI and bio. So on the science, Eric, I really like the way you described what was ready, not what was not ready, because I think that a lot of us were just saying very similar things, but you had a sort of more nuanced view of what was really ready and what wasn't ready in omics, where the gaps were, how that might impact. The idea about text mining tools I thought was very interesting as well. I've heard that a lot of medical insurance companies are doing intensive text mining of written medical records, for example, things like this. So I agree with you that there's other aspects which maybe have been underestimated in lab book collations, things like this, and it's not the major part of it, but I think that a lot of our emphasis was around things that we all knew about, and I was interested when you pointed out some of the things that were less familiar and probably are important. And also this came up, this idea, and I think that this is, I don't know if we even need to discuss this, but the idea of enduring support for data resources, data acquisition, but maybe we have to come back to that again. I don't know, just to make that point.
Mike, can I ask, is it true, or is it worthwhile saying that biology seems to have taken advantage of AI to a very large extent? I don't know if greater, I don't want to claim better than other institutes or areas, but like AI is in biology right now. right? I don't think we have to work to
Yeah.
insert it. And we have really good examples. And I think, we're here trying to say, here's how we can improve it. But is it worth pointing out, like, we're doing a really good job already of putting it into biology.
Not to interrupt, but since he's not here, I think Tom made a very good point that biology is contributing to AI and that there's a two-way relationship there.
So I agree with you. That's why I just thought maybe it's just me. I liked that Eric was a little contrarian about that. Because it made us less complacent in the sense that he pointed out, well, it's not all golden with omics. I mean, I was the one.
That isn't what I was actually talking
No,
about.
yeah,
Sorry.
sorry.
Neural networks.
Yeah, yeah.
Actually, AlphaFold was a AI
Yeah.
advance, not just a structural biology advance.
Yeah.
But this is your guys' meeting.
So I think it's kind of remarkable that we can keep coming to AlphaFold as the example because it's absolutely true. That was a success. It's kind of surprising that we don't have other successes given the wealth of data in genomics, for example, that we have accumulated, right? And I think that goes back to my point.
I think that's Google's marketing department more than anything else. We have lots of successes. Like I mean, we use lots of tools all the time.
Well, tools is one thing. The question is whether, I mean, have we really gotten much about genomic sequence information
Sure,
and
if you want to
predictions?
predict if a mutation that you find is the disease-causing mutation, right? You sequence the parents and the kid. It works. And it's because of AI. Right? That is used at every medical center now.
Oh, sorry, but that was even before AI. We could predict.
And now it's better, but we could predict protein structures too, right?
Well,
I
yeah,
don't
well,
think the
that's-
problems have changed. We've
That's
just
a
gotten
success
better.
case. I'm just saying, what else have we learned? I mean, so the case of the mutations and predicting genetic diseases, we could do it even before AI was there, right? I mean, sure, we can do
AI
it better.
has not given us new kinds of answers, I would argue, to anything.
Oh, I disagree. I think that AlphaFold is an example where we can do things that we couldn't do before. And my question is, do we have another example like that? And my shy answer to that is no, we don't. And the question is why?
To some extent, where regulation lies at the level of, for example, transcript accumulation, machine learning's been effective in getting temporal sweeps of transcription factors, for example, in nitrogen uptake and regulation in plants. So there have been some successes, but clearly the data sets are compromised because they don't look at most post-translational things at all.
Okay.
Or post-transcriptional things, sorry.
Yeah,
Wrong
no,
word.
well, plus, yeah.
Okay. I think it's good. I think it's I think they're both or that it's both it's true. I think it's important. I agree with your point that biology is at the front of this, but there's so much more. I mean, to put it out there, there's, like, to your point, Eric, there's so much more that hasn't been done yet. It's not a time to say we have AlphaFold, we've really improved molecular dynamic simulations. That impacts a very small number of biologists overall nationally. There's a huge number of people who aren't impacted by that at all. So there's a whole spectrum. I mean, that's the thing of the spectrum of bio. That's why we brought up in our discussion, for example, how it impacts organismal biologists.
Well, I think because I think I heard one of the areas that you talked about earlier, which was the promise of AI to really build out our knowledge of spatial temporal relationships in biological systems. And that goes across a lot of different scales of biological organizations. So I think that there's the promise to, I mean, I think I think what I heard you say is that there's great promise in AI for improving our understanding of biological
So
systems.
it's just about couching Eric's message a bit more positively, that there's lots of
Well, I would try to be
potential.
as positive as you can be, because you're talking to to NSF leadership, and I think they want to understand what's the promise, right? Not necessarily dwelling
Yeah.
on what we understand as potential limitations, because we're deep domain scientists, but I think we have to maybe take the conversation up to a slightly higher level. That would be my advice.
Yeah.
I didn't quite follow the whole conversation about AI not having any impact in our, I missed what this.
I didn't say that it didn't have any impact. Yeah, I mean, maybe to rephrase, I think that AlphaFold is a great example. We just need to replicate it into other domains of biology. Okay, and we are making strides in that direction. Where I probably disagree is that we are not there yet. There is a lot still that needs to be done, and there are some challenges that probably deal with having to generate data sets that we haven't even thought about that to be able to improve models.
I don't think anyone in this room would disagree with that.
Yeah,
I think
that's
we've made many strides in addition to AlphaFold. AlphaFold was probably the biggest AI advance of whatever year it was, 2021 or whatever. But there's so many, we see it fly by our updates in, that come into the NSF, everything about what it does, how we take data, how we analyze data is right. It's part of our life now in what Wallace does, what everyone does. So I just want to remind you that those big discoveries, that's not really known to the leadership. So be careful. It's not the only thing is AlphaFold. It's just the most knowledgeable thing we know about, but we are all using, there's many AI, but I agree with everything you said. There's lots we could use it for that we haven't, but it has become part of mainstream biology, everything we do. So there was beautiful antibiotics, etc.
My only thing is, I think that because you're giving us advice, maybe as you talk to Karen, you might pose that as the advice that you're giving us is there's work to really leverage or capitalize on those advances. There's work to be done in the data. You're really hopeful that those synthesis centers will help get us there, or whatever it is that you hope. But maybe the right message, just what is it that your recommendation for us might be helpful in the conversation with Karen.
You're looking at me. I'm going to be addressing this point.
I don't know.
I thought you were doing all of them, Eric.
Are you? I don't know. That's what.
I have some notes if you need mine.
Yeah.
If you need something.
Yeah, Sophie, that's why I'm trying to get through so you got time to exchange notes. We're doing well.
And I guess maybe just to add, I don't think our discussion was as negative as it's being portrayed, putting on Eric this point, but because I think we talked a lot about how in our group about how AI was being used in a lot of different ways, but that it was hard. And so we need improvements even to do the things that we're doing. And then there's all of this potential for further things. So just wanted to kind of clarify a little more.
Maybe one important point to make, and hopefully we all agree on that, is that the way in which we present data to AI needs to be rethought, because raw data might not be the way to do it.
That's one of the points I want to bring up towards the end as well.
You have 30 minutes with her, just to remind you.
I know. That's why I'm trying to keep it on. I'm not going to go back through the schedule, not so we don't. So the next thing I thought was very important, in which directly should follow on from this was, so Matt, you had I like the ideas that some of the things you talked about was kind of the training and the sort of the democratization of AI for current and future PIs. There was ideas about how NSF could encourage that with existing. The NAIR is a fantastic resource which Bio will make huge use of, but as Matt pointed out, the broader impacts actually allow you to train people to promote training in this area, and it's just to make that point, it's existing policies. The idea of I really like this idea of the data management plan being more data AI friendly. That was something that was brought up by Romy. She seemed to have, I thought, good ideas around that, because right now that doesn't seem, I haven't been through this, maybe others can comment. She didn't seem to think that was very well designed in current grant proposals. how you manage data in a way that becomes sort of more productive for AI and machine learning.
I mean, I think my personal view is that current data management plans do what we ask people to do, and until we have standardized formats and make them more useful, we can't ask people to do that on their own, right? So it requires some crosstalk between synthesis centers and other sorts of scientific engagement with that before we can ask people to do it better.
Yeah, so I think that to my mind, this was I think that as Pam kind of pointed out, there's huge potential, but there are some obvious things that we think as PIs NSF can do to encourage this process. So that I'll let you say just a few words about that, Matt. And then, so Maria's not here, is she? So this was an interesting point that several people brought up, and it's come up again now. And this is just, I thought this would, I put this in as a point at the end because Karen's background is in education, is that right? So this notion that we need to get better at articulating questions for AI, and the notion of how we improve science, how we communicate science, how we talk about science probably needs to be rethought a little bit in the AI era. Might be something that is of interest to Karen as an educator, that's something that we might not be teaching people very much. I mean, lots of our students now know that the better they are at asking questions to ChatGPT, the better the response they get from it is, but that's just a sort of on-ramp to how you do this in science. You'll get what you want out, and you'll get better data if you ask better scientific questions. So maybe that could be a good way to end that Karen would appreciate, but I don't know if that's something that would come through bio or would go through a different division in the end.
I think it's important for bio in some ways because of the education of the next generations. And we keep on talking about training in computational biology and so on, or computation. But I think we need to define a little bit better what exactly we're trying to accomplish with that. And asking the right questions is certainly one of those things that, to me, it's even more important than the technicalities.
Should we tie in comments about the rural STEM education along with the EPSCoR comments? Otherwise, that's maybe the only section that's not represented in our comments.
I'm not sure. We don't have timing if we don't have the report. I mean, Hank, you want to say something about the rural STEM? I mean, yeah, go ahead.
I had to deal with something else, so I wasn't listening for a second, but I do hope when she leaves with a sense of where you guys feel, is bio in the right direction? Are there areas that we're completely missing? I know we didn't talk about that, but if you are concerned or you could not concerned, that might be something to, is bio important for the future? Things like that the elevator pitch she might need when she leaves.
So I will say something at the start, when my introduction, because this is honestly how I felt. I felt that AI was very peripheral to what I do, and that I was here to learn about how I would get this better into my college. I had no idea how available it was to me now in my science. And I think that's a very positive thing, that it didn't take very much communication for me to see especially with the NAIR pilot, the potential to bring this in. It's not a feeling that, I think what's been really successful with bio, with the track record and with the NAIR pilot, is the feeling that you're not left behind. With some technologies, people often felt it was too late to catch up. You're not going to get into this. You know, there was this, if you think about, I mean, I know it's a bit dramatic, but some people who never caught up with omics and just stayed in genetics. So I felt much better after I heard the presentations and I saw what the resources were. So I think bio is well positioned. It's just got to keep moving.
And I think Wallace has this hand.
Yes, Wallace.
Well, I don't know if we should say this, but I was really struck by our discussions of what to do about AI and how the discussions were like, how can we catalyze interactions between, you know, biology and computer science and engineering and math. And then also discussions about, well, you know, could ideas from bio or the needs of bio end up drive development of new computer architectures, like maybe more error prone neural networks that can use less power, and just how all of those discussions would never have happened if this was an NIH advisory panel. And we're only having them here because NSF is the logical place to be partnering computer science and engineering with biology, and no one else really does that. And I think that's the point that probably should get made somehow. Because if we don't do it here, no one else is going to do it.
That's the level of comments that I think are very useful.
All right, so
I think they're saying write that down.
yeah. So what I might suggest then is that I'll do the introduction. Hank talks about the EPSCoR, and that maybe I can let Rob, sorry, I don't know why I wrote Ron, Rob talk about postbacks, and maybe Eric and Wallace can say, because I think you both, or Wallace, maybe you could be the one to. So Eric's worried that I've kind of victimized him as Mr. Anti-AI, which I haven't, but he's taking that. So Wallace, if I move this around a bit, I think what you just said really kind of captured everything. So maybe I'll just move the order around and you can be the one that talks about the impact of AI, because I think you also have the anecdotal, I had to drive my truck across the country with all the data, which sort of made a point of where we're at with data. You're muted, Wallace.
Oh, sorry. Yeah, I mean, I can certainly speak anecdotally to the impact it's had on us, you know, on sort of the cell biology microscopy side of things.
Yeah, and I think that would be really, really good. And then I seem to have missed something here. Then have Matt talk briefly about training and democratization of AI. And then I don't know if Pam or someone else wants to say something briefly about how we talk about AI, how we ask questions. I'll try to get
If we have time, I can
Yeah.
do something because that was part of the discussion in our group.
Okay, great.
So Maria brought it up, but yeah, we have notes. Thanks.
I'm actually going to try and get this correct now as the final. Order of things. Okay.
Mike, in the discussion of postbacks, is it worth or would it be going too far into the weeds to talk about with Wallace's data about prior research experiences being a good predictor? In this age of unionization and rising graduate student stipends, that's likely to have a result of making faculty more risk averse. This has the further opportunity of further making it more challenging for those who don't have access to so it's a DEI initiative as well to have these postbacks.
Yeah, I think that's a good way to come at it because Aaron set you up just in case with a.
There we go.
Thank you. No, that's so great. Thank you.
Let me turn my video on. Okay, everybody, great. Welcome. So this is Karen Marangel. She's our Chief Operating Officer, and Brian Stone is the Chief of Staff. Thank you for coming. We've had a really tremendous 2 days. I should say several people had to leave to get their planes, et cetera. So it's quality, not quantity for you. So we are down a little bit, but everything. So we've had as you remember last time, or may not remember, but last time we had the AC, we usually focus on a theme, and we focused on the bioeconomy. And I think last time we reported out how important the foundational biological research was to move on. And that was before we'd done Casa Bio. We informed people about Casa Bio, et cetera. But this meeting, we focused on AI and its interaction and interwovenness with the bio directorate and with the field of biology. We would have actually liked to do a lot of our thought provoking, which was yesterday, but we did it today because everybody was at the wherever expo or wherever they were. But we had great people from SIZE here. We had Michael Littman, and then we had Katie Antipas, and we had one of the chairs of their AC, who's a biologist, Katie's AC, Romeo Mero. She speaks both our languages, so it was terrific. And then we had breakout sessions. So that's pretty much what we did. So I'm going to let Mike take it from here and then ask any questions you need.
Thank you, Susan. Yeah, so we've had I think a very, very good 2 days because of the way we were just talking about the way we've structured things. If you saw other things on our agenda, we had very good discussions around some of the data analysis, around the funding mechanisms and so on. But having the AI discussion today has kind of taken center stage. But just to summarize a couple of things, when we heard at the start about the unexpected budget cuts, and our just one sort of consensus there was that we hope that NSF will continue to favor investigator-driven research, and that the funding cuts won't take a disproportionate toll on that, because we appreciate the need to meet commitments to large existing investments, but we strongly feel that innovation and growth and new ideas come predominantly still through a lot of the investigator-driven research. As Susan mentioned, we discussed the Casa Bio activities, and we were very impressed with that. And there was a general observation that this is important for long-term support of discovery-driven science, and that this is the kind of thing that will help support the bioeconomy in the long run. So we talked about a lot of those things, but we've as you'll see, we'll back reference some of those things, but we've really framed a lot of this in the context of AI, because that's sort of the here and now thing that is really driving bio to a great extent. So I'm going to pass the mic around to various people who will give you a little bit more about some of the earlier topics we discussed, and then we'll really move towards the end about the AI topics. So I'm going to start by asking Hank Bart to say a few words.
Thanks, Mike, and welcome. I'm going to be talking about bio outreach efforts. We had a great, I think, uplifting presentations from Ishita Mukherjee. I hope I'm giving her name correctly. Cliff Weil, both from NCB, Anna Allen from iOS, and Charlotte Ream from DBI. And these were pilot efforts that will focus on EPSCoR states. They involve workshops on NSF funding opportunities at institutions in Arkansas, Oklahoma, Louisiana, Mississippi, and Alabama, which happen to have large numbers of minority-serving institutions, especially HBCUs. The workshops attracted lots of participants. There were teachers, researchers, and administrators in the audience. They learned about writing proposal concept papers, participated in mock review panels, and all facilitated by NSF program officers and other facilitators. NSF got lots of positive feedback from participants. These workshops were held in March. It's too early to tell how many of them will prepare. The participants will prepare and submit proposals, but got our fingers crossed. There was discussion about the importance of planning grants with teaching release time to give proposers time to prepare proposals. Mention was made also of the importance of funding opportunities from the granted program to help institutions develop their sponsored projects, administrations, so that they can manage proposal submission and post-award management. The biggest workshop was held at Alabama State University. It was facilitated by our esteemed colleague and fellow BioAC member, Kennedy Waseka, who had to leave a little early. The next outreach effort will be in EPSCoR states in the Northeast. And so looking forward to hearing about that. I also want to say a few things about a great presentation we had from Suzanne Barber of the Committee on Equal Opportunities in Science Engineering on rural STEM education. Students from rural communities do just as well in STEM performance metrics and graduation as their urban counterparts. Learning opportunities included experiences in rural communities and included experiences with LTERs and NEON sites. Teacher preparation is important to student performance. There was discussion about, after the presentation, about the need for opportunities for students both in their rural communities and colleges in urban areas where they often transition to. So that's all I have to say. Thank you for listening.
All right, thank you. So one of the themes that came up through that in our discussions as well was around the kind of different trainings that this sort of spoke to. So I asked Rob, who's going to talk a little more about different scopes for training.
Hi, and thanks for joining us. The AC, as part of the discussion in response to the pandemic, came down strongly in favor of post-bac training for students. And we continue to think that that's a very important component of workforce development for the bioeconomy that includes, but is not limited to, AI. We talked a lot about data from Wallace Marshall at UCSF, where they've been collecting data on their graduate program, students in the graduate program. And of course, we're always trying to ask what is a good predictor of success. And they have found that the extent of prior research experience was one of their strongest predictors for success in graduate school. I know we at Dartmouth have, without the data, just sort of went for it and identified a subset of students who weren't competitive in the application pool last year, offered them post-bacs. They're now going to graduate school this year. So we think it's, and whether we call it a post-bac or a preparation year or a professional development year, it's all really accomplishing the same thing. We note that in this national tide now of it's tried and true tide of unionization and the consequent rising stipends, if the cost of a graduate student increases, we're concerned that faculty will become more risk averse. And that runs the risk of having a disproportionate impact on students from less resourced schools. So again, we're thinking that the post-bac professional development year becomes a DEI issue. And so and of course, working AI into that is probably a really smart thing. So those are our thoughts.
If I could just comment on that, I'm really excited. I thought that it was such a great recommendation for NSF, the bio directorate, to focus on post-bac education. And I love that you're continuing to iterate on this and think about where there's data that's pointing to promising practices. I think this gives us a lot of food for thought about some of our programs. Are there ways that this could connect to the research experiences for undergraduates program in some way, that especially in biology with the large post-bac community that you all have, and that you are thinking about AI training and tools in some of that. I think I would encourage you to continue to give this additional thought and continue to bring us recommendations about how we can strengthen and grow this program. It is a important cadre of students that often gets overlooked. So I've really been pleased by the attention to that and glad to hear that that's a continuing part of your conversations.
And so that's a good segue. So when we moved into the AI part of our meeting, our discussions, so what we're going to try and do is first to tell you a little bit about the kind of scientific side, the successes, the future potential of AI and machine learning in biology, and then a little bit about how, in addition to the postbacks and other programs, we think that some of the things that NSF does now can be utilized to advance that, and some new things that might possibly be done. So we're going to start with Wallace is going to take, is Wallace there?
Yes, I'm here.
All right, so Wallace is going to tell us a little bit about the biology side of this first.
Yeah, so there were two things I wanted to say. So the first is that, I mean, there's a lot of excitement about the use of AI in protein structure prediction. So it's having a huge impact on biology in that respect. But one thing we talked about is how now there are, really every area of biology is starting to use AI as a tool to various extents. And it's because we're drowning in data and no one knows what to do with all of that data. And so AI holds out the promise of being able to handle that. In many cases with microscopy data, we're still going through by hand and saying, okay, here's where the cell is. And AI is making that really a lot easier. So it's becoming a more widespread tool, and that creates the need for getting people on the biology side to know how to use these approaches. And that requires, innovative ways of training our students and faculty, and also ways of catalyzing collaborations. And one of the issues that we identified is that, these are two different worlds here, computer science on one hand, biology on the other. How do you get them to talk to each other and how to understand each other and have mutual respect, so that the biologists are not just demanding that some computer scientist person just does something for them? How do the biologists understand the interests of computer science colleagues and vice versa, so they can work together? And so we had some discussion about possibilities of things like, hackathons to bring the communities together and identify collaborations. But what was striking in all these conversations, it's always about how do we bring together these different disciplines. And what's striking, what we wanted to point out, is that this conversation really only could happen at the NSF. There is no other funding agency that has both computer science and biology under its purview in the same way. NIH would not be able to do this at all. And so we had the sense really that if NSF doesn't do it, nobody else is. And so we just want to recommend this as a very high priority area.
That's fantastic. And I agree. This could only happen at the NSF. I love hearing that. I would also encourage you, so as a mathematician, mathematicians and biologists have been collaborating for now like several decades, and there may be lessons to learn, because I think there was a resurgence or a surge in that collaboration some time ago. And I certainly remember some of my colleagues in the math department working with biologists, and that translation, that coordination that needed to happen across the disciplines, as you point out. You already have experience doing this, so drawing on some of those past collaborative efforts to make your tools more efficient, to really use some of the leading technologies, you have a good foundation for what has worked and like where there's been problem areas that can and should be imported into the work that you're doing with AI. But I acknowledge that as a field, you have really been innovative in collaborating with other disciplines, and I think there's a lot to grow from there.
Okay, so to enable that growth, we have some ideas about. So I'll preface this with saying that I felt very good about NSF and where NSF is going to enable people like me to use AI, and I felt good about how I can share this. But we also talked about some existing mechanisms which could be utilized to maximize engagement with AI for researchers going forward. So Matt Hahn's going to talk a little bit about that and some related topics.
Yeah, so we thought if Mike could use AI, anyone could. And how best to introduce AI to the future STEM workforce or current PIs, right? I mean, that is a big obstacle, and grad students. So we had a few ideas, one of which, I mean, we heard about the NAIR pilot today, and I guess it's 3 days old since it's gone public. So that seems great. Jetstream seems great. Just any opportunity there is to advertise the resources that NSF puts in front of PIs or future PIs would be great. The other idea we had was about using broader impacts and related mechanisms that are already in place for getting people to get more training. So if we put into broader impacts, training students, whether that means creating your own course or getting students into workshops where they can be trained through NAIR or through other programs, through postdoctoral mentoring plans, saying, okay, the postdoc will be mentored, through postdoctoral fellowships, saying NSF fellowships that we give to postdocs, they're also going to come with training if the person wants it in these areas. The last area, which I'm going to mention, because it gets a little bit complicated, is in data management plans. So all of AI in biology runs on data, and probably all of AI everywhere. But in order to make that happen, you need standardized data. And so in order for us to start asking people to standardize their data and their data management plans, we also need ideas about what each field needs and how they're going to standardize it. So, we had some ideas about using synthesis centers or other centers for doing that, but in the long term, that's what we need.
I'm going to feel like a broken record, but again, I'm going to point you back to like you modeled this work in NEON. I mean, that is amazing. I have actually pointed other disciplines to what is happening in NEON, exactly around the standardization of data collection and just the standardization across data. I hear your point exactly, and I think it's really important to be thinking about the types of trainings that for current PIs, for future PIs, especially for students, that we should be building in to our grants, because without that, there's, the field is going to be left behind from the advances that are happening. So this is really, really important. And I would encourage you all to think more, even broader about some of that data standardization, very important in your fields because it's so data
I think it
rich.
hasn't been mentioned yet, but I mean, we talked about it over and over, but the PDB, which is NSF funded, right? It has standard data that was used by Google and others to create amazing protein prediction platforms. Without that database, without those data formats, none of it happens.
Yeah, and also we did, this came up occasionally, it was the idea of enduring data that came up through the PDB. The PDB is, we all take it for granted as enduring data, but I think someone mentioned this, the notion of how you ensure that data remains available over a prolonged period was important in different areas. So what we also, when you brought this up just now, Karen, about educating PIs and future scientists. An interesting topic, which Pam is going to talk about, but I think other people would comment on as well, is kind of the broader question of how you do science in the AI era, which is something we haven't thought about so much as we should.
Yeah, so we think that there are some additional perspectives on this theme of education and training in relation to AI. So probably, I think this is true, that most of us as a community think about how we can teach about AI and how to use AI, what AI is and everything. But there is also sort of the reverse, like what can we learn from AI, or how can we use AI in educational approaches? So it's sort of worth considering some of these other connections between AI and education. So for example, maybe instead of teaching our students how to code, we teach them how to use AI to teach them how to code. And so the AI itself can be teaching the coding rather than us teaching them how to write code that they can just as easily, students could just as easily check using AI tools. And similarly, and maybe more importantly, instead of teaching some of these very sort of basic skills, maybe we should be teaching more about how to communicate about science and what our science means. And so in order to actually be able to write effective code, one needs to be able to say, this is the problem that I have, and these are the questions that I have. So So we think that actually the AI sort of, approach allows us to address some of these other questions about education, like how do we teach students how to ask good questions? How do they evaluate whether they're asking the right questions? And all of this sort of loops into the whole computational aspect. And then one other point that was brought up through our discussions was that, in fact, we might be able to use AI to help us learn more about how we think. And so the whole concept of cognition and what AI can teach us about that provides us with yet more opportunities. So it seems like there are some good opportunities going forward in education and AI at that nexus, but maybe in directions that haven't been considered as much. And we think there's some exciting possibilities there.
Love this. I wish I was in the room for some of these discussions. I couldn't agree more. And what's really exciting about AI, so I love the examples that you've given. And again, I encourage you to continue to think and discuss this, because AI does have the opportunity for us to be rethinking our curriculum, to really streamline, make efficient some of the things that are in our curriculum currently, because it is a tool to help students think. It's a tool for all of us to help us think. It is a thinking tool. And so are there aspects of our curriculum that should be changed and should be really offloaded and de-emphasized to make room for some of the more exciting topics and some of the exciting tools and resources that students really need to be trained up on as we think about the future of any science and biological science moving forward. So this is a very rich area. I think it's an area that people are treading on very carefully. Our curriculums are set. It's very hard to change them. They're so stagnant, but we need some folks to really raise their hand and say, hey, we're going to move forward with this. We're going to try something new because we think this is going to be better. We're going to collect the data and evidence to show what can happen. But I absolutely love that you're having these types of conversations, and there is so much possibility here.
Maybe if I could just follow up, one of the actual suggestions that was made in one of our breakout groups was that perhaps we could even use AI to help with the assessment of the new learning methods. And so it seems like there are really a lot of potential possibilities.
Yeah, absolutely. I mean, and as a mathematician, I think there's a lot of mathematics that students, we don't need to be spending so much time on what we're teaching students. And when I talk about freeing up the curriculum, it is precisely in that space. Do students really need to be taking all of the math classes they're taking right now so that they can engage with some of the science that's really exciting? We can get them to some of these open questions much quicker because AI can help them. And yes, there are still opportunities to think conceptually and learn. And yeah, you have to have the ability to look at what AI is generating. You have to be able as an individual to assess that, to talk about it. But that I think can really the timeline in doing that can be shortened. So many really exciting possibilities here.
So I think we needed you in the room when we had this discussion about whether or not we needed to advocate for more biostatistics classes or not, because that was kind of a, no, you don't, yes, you do. So you should have been here. You could have mediated that. It helps us. No, I think that summed it up well, because I can't remember, I think maybe it was Eric or someone else said there's so much data. And the question is, what do you ask of it? Yeah. You even know how to ask of it, but what do you ask of it is a question we haven't thought enough about still. So we came awake feeling quite optimistic, I think, about things. And that's after our meeting started with a budget cut. So
this is good.
Actually, so I got an email from a member who left to make sure you included something important, which is, and I just think it got lost in the conversation, is that there's the opportunity for bio to drive AI as much as it is for AI to drive bio and to make computers more efficient and things like that. And so he really wanted me to make sure that we brought that forward.
Yeah. I totally agree, and I think some of our conversations here within the agency have pointed that out. That right, there's no one person, certainly on AI, driving this anymore. It's not the computer scientists, and the different disciplines are going to continue to grow and shape AI as we know it, use it now, and what it's going to become in the future. It's a great point.
Anybody else got something they'd like to bring up that we left out? It's your opportunity to speak to the top. No, well, thank you so much, Karen. Thank you, Brian. We really appreciate you stopping by. Do you want to add anything?
Any comments?
I'll just mention one thing. Let me just say to the AC, your bio team here at NSF has done a tremendous job defending the interests of bio in the interagency process. It's not always been easy, and I'm sure they've filled you in on some of the trials and tribulations of that, but they've done a really great job on dual use and making sure that that biologists have access to things they need to for years to come. So we do a lot of work with your team, like I said, on the policy stuff, working with the White House, the interagency. You've got a really good group looking after the interests of the community. So.
And just want to say thanks to all of you. The director sends his thanks and greetings to you. And it's discussions like these that really keep us grounded. Your recommendations to us are very, very, very important. So please know that. The input that you give us really does feed into the decisions that we're making and the way that we're thinking about the work that we do. So I just want to thank you, because this is an investment of your time. You are all very busy, and we really, really appreciate you taking the time to spend 2 days with NSF and our great colleagues here. So thank you.
Thank you.
Thanks. Brian was a bio major. Okay.
Many
Have a
moons
good day.
ago.
See you later.
Thank you.
Thanks.
Thank you. Nice to see you.
Nice to see you. Thanks. Okay. Is the airport team leaving?
Okay, I think we just have, and we don't have to do this, but I think if you have, first of all, thanks to everybody, obviously, but we will plan, I don't think it's scheduled yet, Karen, right? So for the next meeting, but we've always tried to have a theme that's a useful theme. And so you don't have to say it now. It seems like we're dwindling, but give us input so that we are engaging you in a way that's appropriate. And again, you're our representatives out there. So if there's things that, oh, I'm sorry, Wallace from the
Well, I had an
car.
idea for a theme, but I didn't want to interrupt you while you're talking about the need to talk about themes. So,
No, give me your theme.
well, because it already came up, which is the impact of the salary escalation for students and postdocs, and we're really feeling it here in the UC system, probably more than most people here. And I'm not kidding. It's basically, I'm not going to be able to recruit postdocs probably ever because I can't afford them. And even the grad students are, the lab's going to have to be a lot smaller. And so I think the question is going to, assuming that this catches on nationwide, which I kind of hope it does. Otherwise, we're going to be really screwed in UC. But assuming it catches on nationwide, the question becomes, well, how can funding agencies help us continue to do great work with effectively much less money, because we're going to get the same amount of money, but we can only pay for, 3/4 or a third as many people. And so, I have some ideas about that. Like, are there ways that we could at scale harness, CROs to outsource more of the sort of, boring work, like the same way we do for DNA synthesis. But I think it's going to be a real issue for bio, especially where typically the work has been done by large groups of, students. It's not going to be, I don't think it's going to be as really possible going forward.
Thanks, Wallace. You've channeled me because obviously I live across the bay from you
Yes,
in my other life. But it's something we should think about, but I just want to rest assured it's something we think about a lot here. And it's very clear. And the postdoc issue, most postdocs are in the bio field, just nationwide. So so we are taking the lead to try to think about these problems, but we'll write it down as a potential idea. Thanks.
One thing, Wallace, I think Karen said next time we might have the report out from the budget. The graduate student stipend issue did go somewhere, didn't it? It was being discussed.
Sorry, if there is information from the NSB, we will certainly report that out to you. And as we make our decisions and they become public of postdoc salaries, et cetera, we will report that out to you. Is that, am I? So good, thank you. Are there any other suggestions? Yeah, Pam.
One of the other topics that came up as a potential topic, and I thought it sounded interesting, was something on team science, just because, well, primarily because it's it's a very important part of the synthesis centers and a number of the other large projects like the BIIs and things. And it might be interesting to hear some assessments of how that sort of thing has gone.
So there's related to that. So the BIIs, so the BII I'm on has one of the PIs is the science team, and we set up the RCN, which was helping the rest of the BIIs around this. So this might be something as a mechanism worth discussing.
We just got invited.
All right.
It happened after. Yeah, we don't. Our many starts in June, so we missed this last year. So I didn't realize that was the theme of that.
I think it's interesting because it seems to be limited to who knows about this and who does this in the broader bio community.
We have an advisory board member who's a science and team science person. But
Great. So maybe I think we'll just thank some people and then we can turn everything off and talk.
One last thing.
Yes, of course,
so
you're
it's
running
because
meetings.
last time, whether it wasn't last time, it was the time before when Ponch was there. He asked us to discuss K through Gray, and we never did. Is that kind of gone now? Was that has he moved on to other things?
Well, creating opportunities everywhere is still a major thing with NSF. So it's, there's still having a lot of discussions on what that's going to look like going forward. So it's not off the table.
Okay, that's another one. Great. I think everybody heard you. Okay. Great. So before we go, there's I always have to thank my dad here, Simon, of which I do nothing without consulting my deputy assistant director here. But in this particular incident, the main drivers, as we know, Karen, who we see all the time, who without all of the organization. So thank you, Karen. This would never happen in any smooth way without you. And now we'll let you sleep this weekend. And then we have Melody and where are you? Oh, there you are. You switched. And Loretta, I'm sorry, down there. And we are, I think that, and all of the program directors, and especially to me, if you could all thank your program, we have the senior managers here, but we also had a lot of program directors and staff that came and talked to us, which I personally felt was a highlight to hear it from people that actually know what they're talking about. So please relay that to them. Not that you guys don't know what you're talking about too, but you know what I mean. Anyway, so thank you. And do I say something like the meeting is, or does he, or you have to do something?
I can see Karen.
We're not following the script.
We're not following the script. So he's like, a debrief. We're not going to get good points, are we?
Yeah. but
Okay.
I could thank.
I
Paul
hereby
again.
adjourn the meeting.
Oh, you say that. There we go. Great. Thanks, everyone.
When you end it.
I want to say thank you to the new members too, Wallace, Matt, and Pam. We're happy to have you here and look forward to working with you in the coming years.
It was fun. I'm looking forward to the meeting at McMurdo Station. That happens.
Yeah.
Oh, bye, everybody.